In this problem, we're asked to find absolute maximums and absolute minimums for the function 2 cosine 2x minus cosine of 4x. And the absolute minimums and maximums we're only concerned with on the interval 0 to 2 pi. And those will occur either at the endpoints or when the derivative equals 0. The maximum can occur when the derivative changes from positive to negative, and the minimum will occur when the derivative changes from negative to positive. So we have to consider the endpoints and the critical points of the derivative, where the derivative equals 0 and the derivative is undefined. The derivative of f is equal to the derivative of cosine 2x is equal to negative sine, so this becomes negative 2 sine of 2x times 2 because of the chain rule. We've got to take the derivative of the inside, 2x. The derivative of cosine 4x would be sine of 4x times 4 by the chain rule. So if we begin to clean this up, this is 4 sine of 4x minus 4 sine of 2x. And in order to evaluate this without a calculator, we need to use a number of trig identities. So if this was a calculator exclusive problem, then what I would do is graph this and look at all of the values where it equals 0. But let's assume we want to at least come up with the critical points by hand. There's a couple identities you need to be aware of. The first is that the sine of 2x is equal to 2 sine of x cosine of x. Implied in this, then, is that the sine of 4x, which would be equal to the sine of 2 times 2x, is equal to 2 sine of 2x cosine of 2x. And because we have cosine 2x appearing, there's a number of different identities for the cosine of 2x, and the one I'm going to use is 1 minus 2 sine squared of x. So we'll use all of those identities, which ideally you have seen before, and perhaps you've even proved them in a pre-calc or an algebra 2 class. So by substitution, if I substitute for sine of 4x, this will become 8 times the sine of 2x cosine of 2x. If I substitute for sine of 2x, this will become 8 sine of x cosine of x. Continuing to substitute, first I'll substitute for sine of 2x. So this will become 16 sine of x cosine x. And at least for now, I'm going to leave the cosine of 2x alone. I'll clean this up first. So minus 8 sine of x cosine of x. This currently has a common factor of 8 sine of x cosine of x. So I'll factor that out. When I do, I'm left with 2 times the cosine of 2x minus 1. Substituting again, the cosine of 2x is 1 minus 2 sine squared x. So this will become 2 minus 4 sine squared of x. When I distribute into 2, minus 1. And finally, cleaning this up just a little bit, I have 8 sine of x times the cosine of x times 1 minus 4 sine squared of x. And again, this is what I would need to do if I had to do this by hand. Right? I've just got to recall my trig. Now, I don't think there is, as a general rule of thumb, you should not expect a problem like this on the AP exam in a non-calculator section, because this would not be the kind of thing anyone would want you to do on the AP exam, because so many mistakes could be made just getting to the actual calculus. Right? So this would be a calculator problem most likely. But since we're here, we want to know when this equals 0. 8 sine of x equals 0 when x is either equal to 0 or pi. Cosine of x equals 0 when x equals pi halves or 3 pi halves. 1 minus 4 sine squared of x equals 0 when they equal each other, which would occur when the sine of x is positive or negative 1/2. And this happens at 4 different values: pi sixth, 5 pi sixth, 7 pi sixth, and 11 pi sixth. It's important to note that you must always be working in radians, and it's important that you know your trig identities for pi sixth, pi fourths, pi thirds, 0, pi halves, and then all of the corresponding angles in the other 3 quadrants. From here, I'm going to take some liberty and use a calculator to identify mins and maxes. If I had to do this by hand, we would be substituting in, using some sign analysis to try and decide when is this thing positive or negative, and we would also have to check the endpoints. But from these critical values, what you find is this. As I set up my sign analysis, I recognize that 8 sine of x would also be 0 at 2 pi. And we can see, looking at the graph of the derivative, that between 0 and pi sixth, it is positive. Between pi sixth and pi halves, the derivative is negative, changes to positive, goes back to negative, back to positive, back to negative, back to positive, and negative. So we can identify possible maximums would be pi sixth, 5 pi sixth, 7 pi sixth, and 11 pi sixth, along with the endpoints. The reason that those are all possible maximums is because the derivative changes from positive to negative there, so it goes from increasing to decreasing, the original function. And we have minimums, absolute minimums potentially at pi halves, pi, 3 pi halves. 0 and 2 pi are also possible minimums because from 0, the graph increases out of 0, right, since the derivative is positive. So I know it could be a minimum, it can't be a maximum. 2 pi could be a minimum because the derivative is decreasing or is negative going into 2 pi, which means the original function is decreasing into 2 pi. By process of elimination and some calculator use, you will find that you have that the maximums occur, absolute maximums occur at pi 6, 5 pi 6, 7 pi 6, and 11 pi 6 because the function's value at that point is 3 halves at all 4 of those points. And you will find that the absolute minimum of the function occurs twice. It occurs at pi halves and 3 pi halves, and that's because at both of those values, the original function equals -3.